Hello everyone, hope you all are doing good. So let's start solving today's problem. So today's problem is about number of good components. So alright, now before I move on with the problem solving, I would like to request you all to subscribe the channel to get daily notified explanations and make your DSA strong. So now on that note, let's get started. So the problem has asked us to find good components in this particular graph and a component. A component is said to be a good component only when the component is fully connected. Now what does that mean? That means each vertex in the component should share an edge. This vertex is sharing an edge with this vertex. This vertex is sharing an edge with this vertex. Also, this vertex is sharing an edge with this vertex. That means this is a good component. Similarly, this vertex is sharing an edge with this vertex. But this vertex at the same time is not sharing an edge with this vertex. That means this cannot be considered as a good component. Similarly, what about this component? This vertex is a single vertex since it is not having any other vertex to share an edge. So this can also be considered as a good component. So the component count, therefore, the good component count therefore becomes 2. So here we are getting the output. Now before moving forward, let's observe something. For a single vertex, the edge count is 0. We are not having any edge. For two vertices, the edge count is 1. This vertex can only be connected with this vertex via a single edge. So the edge count is 1. Similarly, for three vertices, the edge count is 3. Here as you can see in this component. So the edge count is 3. Similarly, for four vertices, how many edges are required? These two vertices are connected by one edge, 2 edge, 3 edge, 4 edge, 5 edge and 6 edge. So for 4 vertices, we will require 6 edges. So for single vertices, we are getting edge count as 0. For 2 vertices, we are getting edge count as 1. For 4 vertices, we are getting edge count as 6. So can we say for n vertices, we will have n into n minus 1 by 2 number of edges? Can we say this? After applying this formula, you will get the edge count similar to these edges. The n here denotes vertices, the number of vertices. So now let's move forward. So what we will do is that we will simply perform DFS now of each component. Now while performing DFS, what I will do is that I will count the edges, the number of edges in each component. So if I perform DFS, the number of edge count is 1, 2. So here the number of edge count is 2. And the number of vertices is 1, 2, 3. The number of vertices is 3. So while performing DFS, I will count the number of edges and the number of vertices. Now why? Because if I get this number of vertices, I will apply this formula. Here n denotes the number of vertices. So number of vertices is 3. 3 into 2 by 2. After applying this formula, I am getting the number of edge count as 3. But here I am getting an edge count as 2. Now what does that mean? Since my edges after performing DFS and my edge after applying this formula is not matching, that means this is not a good component. Similarly, let's apply this. While performing DFS, I will count the number of edges. What is the number of edge count? 1, 2, 3. So the edge count here is 3. Also, the vertices count is 3. So for 3 vertices, we have calculated here as the number of edge count will be 3. For 3 vertices, I am getting the number of edges as 3. Since here also, while performing DFS, I have got the edge count as 3. And after applying the formula, here I have got the edge count as 3. Since this is matching, so this is a good component. I can say this. Similarly, then while performing DFS for this component, I will get the number of vertices as 1 and the number of edge count as 0. So I will apply this formula. I will again apply this formula. So after applying this formula, I will get 1 into 0, which will automatically give me 0. And this gives me my edge count. Since my edge count here after applying the formula and after performing DFS, I am getting the same edge count. So I can say that this component is a good component. So this is how we will be performing. Now, how to implement this logic? So to implement this logic, we will be performing DFS, and to implement DFS, we will require a visited array, which is initialized to 0. Now what I will do is that I will start a for loop, and for each node, I will see if it is visited or not. If visited, then that means DFS has been performed. So I won't perform DFS. So let's do. I will start performing the DFS from node 1 till the number of vertices. Here the number of vertices are 7, so it will run till 7. Now my I equals to 1. What I will see is that is my I visited or not. If not visited, what I will do is that I will mark the visited array 1. Here my I is 1. Let's see. Here it is marked as 0. So this is not visited. My node 1 is not visited till now. So mark this as 1 and simultaneously calculate the number of vertices, that is 1, and the number of edge is, it is sharing one edge, so the edge count will be 1. Now what? Again, perform DFS. Now it will move to this adjacent node. So is 2 visited or not? No, 2 is not visited. So mark this as visited since we have now visited, and update this vertex count to 2 and sum up my edge to how many? This node is sharing an edge with this node and the second edge with this node. So it is sharing two edges with their adjacent nodes. Similarly, now move to this node. Is 7 visited? Let's see in the visited array. No, it is not visited. It is still 0. Mark it as 1. After marking 1, what I will do? Increment the vertex count to 3 and let's see how many edges are there. 7 shares a single edge with this vertex, that is 2. So the edges will be 1. Now summing it up, you will get 4. But wait, earlier we were getting the edge count as 2 and here also we can clearly see here that the edge count is 2. So no need to worry, simply divide it by 2, you will get your exact edge count. Now what? After that, is there any other node to be traversed? No. So it will return back, it will return back, it will return back. After that, what I will do? I will see if my edge count is similar to this formula or not. So after checking this, you will see that no, this is not similar. Earlier we were getting, after applying the formula, we were getting the edge count as 3 and here we are getting the edge count as 2. So this is not a good component. Fine. So my I was earlier 1. So now it will be updated to 2. But here, wait, my 2 is already visited. So I won't visit it again. So it will now update to 3. Is my 3 visited? No, 3 is not visited. So apply DFS. This is my 3. Mark this 3 as visited. And for this component, my vertex was initialized to 0. Now my vertex count will become 1. How many edges are there? This vertex is sharing a single edge with this vertex. This vertex is sharing a single edge with this vertex. So the vertex count is 2. Fine. Move to here. To this adjacent node. Is 4 visited or not? No, it is not visited. So mark it as visited and make the vertex count as 2 and the edge will sum up to 2. Why? Because 4 is sharing an edge with this node and 4 is sharing an edge with this node. Similarly, now I will perform DFS again. So it will now point to 5. Is my 5 visited or not? No, it is not visited. So mark it as visited and make the vertex count to 3 and edge count, sum the edge count as 2. Why? Because 5 is sharing an edge with 3. Also it is sharing an edge with 4. So the edge count will become 2. After summing it up, you will get the answer as 6. Divided by 2, you will get 3. So if after performing DFS, you are getting 3. After applying the formula, you are getting a 3 here. So since this is matching, so you will return this as your good component. So my count is now 1 for this good component. Similarly, my I was earlier 3. Now my I becomes 4. But wait, 4 is already visited. Is there any need to visit it again? No, not needed. Move to 5. Is 5 visited? Yes, 5 is already visited here. No need to visit it again. Move to 6. So now it will point to this node, that is 6. Mark this 6 as visited because it is not visited. So mark this 6 as visited. Now count the vertex as 1, increment your vertex count as 1, and edges. Do we have any edge here? Is this node sharing an edge? No, it is not. So the edge count is 0. Fine. So the DFS will end here. Alright. Now, earlier, my I was 6. Now it will point to 7. Is my 7 visited or not? Yes, it is earlier visited. So no need to visit it again. Here it ends and you will return your count as 2. You have counted this 6 here too. So I forgot to update this 3. So you will return this, your count as 2. So here's how you are getting your good component count as 2, which is same as your output. Now let's implement the code. So I will require an answer. Let's name it as good. So this will count the number of good components. Now here we are given with the edges and here we need to convert this into adjacency list. So let's convert this into adjacency list. I0 So this is how you will convert into adjacency list. You will get your adjacency list. Now what? Now I will require a visited array with size v plus 1, and the array will be initialized to 0. We were initializing this visited array to 0 at first. So here also we are doing the same thing. Now what? I will check for each node if my node is visited or not. If it is not visited, what I will do? I will initialize my edge count as 0, my vertex count as 0, and I will perform DFS for each node here. Here, for each component, I was initializing my vertex to 0, I was initializing my vertex and edge to 0, I was initializing my vertex and edge to 0. So for each component, I was counting vertex and edges separately for each component. Also, I was seeing whether my node is visited or not, whether my node is visited or not. We were doing this I equals to 1. We were starting from I equals to 1 till 7. We were observing whether it is, we were seeing whether it is visited or not. If not, we were marking it as visited and counting the vertices and edges. So we are doing the same thing here. After performing this DFS, what we did is that we were doing edge by 2 because we were getting 2 into the edge. So dividing this by 2, we will get our actual edge. After that, we were checking this condition. If my edge count is similar to the edge count after applying this formula, then we were considering it as a good component. If not, we were not considering it as a good component. So here, if this matches, then we will make it as a good count. At last, return the good count. Also, at the same time, let's implement the function DFS. So we are passing the node here. We are passing the adjacent list here, the edges here, the vertex, and the visited array. Now what? We were marking the visited array. If not visited, what we were doing? We were simply marking it as 1. We were incrementing the vertex. We were incrementing the vertex, and we were summing up the edges here. So let's sum up the edges. After that, we were checking for the adjacent nodes here. If my adjacent node is not visited, we were performing the DFS again. If my adjacent node is not visited, we were performing the DFS again. So we will do the same thing here. If not visited, I will perform the same thing. So this is what our code will look like. Now let's compile and run. Okay, so here we are getting correct output. Now let's submit. So yes, here we are getting correct output. The code has been submitted successfully. The problem has been solved successfully. So do subscribe the channel to get more such coins popping up on your screen. I will be maintaining this streak from now on. So if you want to do the same and conquer DSA with me, hit that subscribe button, give this video a like, and share this with your friends. Thanks a lot for watching. I will see you guys again tomorrow.